Hello, my dear students. I am Aditya Chakraborty, Assistant Professor of Electrical Engineering Department of Sri Ramakrishna Institute of Science and Technology under Swami Vivekananda Group of Institute. Today, I am going to discuss about the Part 2 video lecture of Circuit Interrupting Device. So before discussing about the topic, we have to know what is circuit breaker. So circuit breaker is a device which can make or break a circuit manually or automatically. Or you can say circuit breaker is a device which can use to separate the faulty electrical part from the healthy electrical part automatically or manually. You can see here an image of substation where the oil circuit breaker is installed. During the separation of contact of circuit breaker, that means during the separation of fixed contact and moving contact, due to large fault current and high current density at the contact region, the surrounding medium ionized. That means when the fixed contact is separating from the moving contact, due to the high current, there is a high electrical stress in the contact point or in the air gap between the two contacts. And the surrounding medium ionized, and thus a conducting medium is formed, and this is called the arc. That means arc is a conducting medium from where the current is flowing. This arc in circuit breakers provides the low resistance path to the current, and the current in the circuit remains uninterrupted. So then from this arc path, which is a low resistive part, the current is flowing from the fixed contact to moving contact without any interruption. And when a short circuit occurs, a heavy current flows through the contact of the circuit breaker before they are opened by the protective system or protective relay. Now, at the instant when the contact being separate, that means at the instant when the fixed contact is separated from the moving contact, or moving contact is separated from the fixed contact, the contact area decreases rapidly and large fault current caused increases current density, hence rise in temperature, and the current produced in the medium between the contact, it may be usually oil or air, is sufficient to ionize the air or vaporizes and ionizes the oil. And this ionized air or vapor act as a conductor, and an arc is struck between the contacts. So when the medium is ionized, then the current is flowing through the contact, and the potential difference between the contact is quite small and just sufficient to maintain the arc. So due to a low potential difference, there is a current is flowing and the arc is remain persist. The arc provides a low resistance path, and consequently the current in the circuit remains uninterrupted so long as the arc persists. That means there is a electric arc is produced between two contacts of a circuit breaker. Now the factors affecting the arc resistance. At first you have to know what is arc resistance. Arc resistance is a term which is used to reduce the arc. If the arc resistance is increased, then the arc is reduced. So during the arcing period, the current flowing between the contacts depends upon the arc resistance, The greater the arc resistance, the smaller the current that flows between the contacts. The arc resistance depends upon the following factors mainly. Number first is the degree of ionization. If the ionization is reduced, then the arc is also reduced. That means the arc resistance increases with the decrease in the number of ionized particles between the contacts. So if the ionized particles is decreases, then the arc is also decreases. That means the arc resistance is increases. Length of the arc resistance increases with the length of the arc, that is separation of contact. When the contact separation is more, that means when the air gap between the fixed contact and moving contact is increases, then the arc resistance is also increases and this arc is minimized. And cross section of the arc resistance increases with the decrease in area of cross section of the arc. So if the area of cross section of the arc is reduced, then the arc resistance is also increases. So these are the factors affecting the arc resistance. Now the principle of arc extinction. So before discussing the method of arc extinction, it is necessary to examine the factor responsible for the maintenance of arc between the contacts. So the following factors are responsible for arc between the fixed contact and moving contact of circuit breaker. Number one, that is potential difference between the contact, and number two, that is the ionized particle between the contacts. So when the contacts have a small separation, the potential difference is sufficient to maintain the arc. So when the moving contact is just separated from the fixed contact, then potential difference is very high. One way to extinguish the arc is to separate the contacts to such a distance that potential difference inadequate to maintain that. So if the separated area between the moving contact and fixed contact is increases, or if the air gap between these two contacts is increases, then the potential difference is inadequate to maintain the arc. That means it is reduced, the potential difference. So arc is extinguishes or arc is reduced. However, this method is impractical. This is simply impractical for high voltage system. Okay, because in case of high voltage system or extra high voltage system where circuit breaker is used, many meter of separation may be required for that process. Okay. Number two, the ionized particles between the contacts tends to maintain the arc. If the arc path is deionized, if we deionise the arc path, or if the dielectric strength of the arc path is increased, then the arc extinction will be facilitated. This may be achieved by cooling the arc or by boldly removing the ionized particle or sweep the ionized particles from the contact space. Okay. So this is the principle of arc extinction. Now, there are mainly two methods of arc extinction. Number one is high resistance method, and number two is low resistance or current zero method. So at first, the high resistance method. In this method, the arc resistance is made to increases with time so that current is reduced to a value insufficient to maintain the arc. So if the arc resistance is increased, then the current is reduced and the arc is extinguished. The principal disadvantage of this method is that enormous energy dissipated. If the resistance of the path is increased, then the enormous energy is lost or dissipated in the arc. Therefore, this arc extinction method is employed in only DC system or DC circuit breaker and low capacity AC circuit breaker. We can't use in AC circuit breaker, because in case of AC circuit breaker the voltage is very high. So if we employ the high resistance method, then efficiency of line is reduced. So arc resistance increasing methods are as follows. Number 1, lengthening the arc. The resistance of the arc is directly proportional to its length. So the length of the arc can be increased by increasing the gap between the contacts. Cooling the arc. Cooling helps in the deionization of the medium, or we can increase the dielectric strength of the medium by cooling the arc. So cooling helps in the deionization of the medium between the contacts. This increases the arc resistance. Efficient cooling may be obtained by a gas blast direct along the arc. So reducing the cross section area. If the area of cross section of the arc is reduced, the voltage necessary to maintain the arc is increased. In other words, if the resistance of the arc path is increased, that means if the area of cross section of the arc path is reduced, then the arc path resistance is increased, as I have already told in previous slide. And the cross section of the arc can be reduced by letting the arc pass through a narrow opening or by having a smaller area of contact. So if we used a small channel by which the arc is flowing, then the arc path cross-sectional area is reduced. And number 4, splitting the arc. If we split the arc, that means the resistance of the arc can be increased by splitting the arc in many parts. Okay, so that means if we split the arc in number of smaller arcs in series, each one of these arcs experiences the effect of lengthening and cooling. The arc may be split by introducing some conducting plates between the arcs. Okay, if we placed some series plate between two contacts, that means between moving contact and fixed contact of the circuit breaker, then we can split the arc, and by those method the arc resistance can be increased. Now the low resistance or current zero method. This method is employed for AC circuit breaker only. Okay, so this method is employed for arc extension in the AC circuit only. In this method, arc resistance is kept low until current is zero, where the arc extinguishes naturally. When the zero position is arrived or achieved, then the current is zero. That means the arc extinguishes and is prevent from restriking in spite of the rising voltage across the contacts. So the voltage cannot be rise because the current is zero. All modern high power circuit breaker are the low resistance circuit breaker, or the low resistance or current zero method is employed in case of AC circuit breaker. In an AC system, the current drops to zero after every half cycle. At every current zero, the arc extinguishes for a brief moment. Now the medium between the contacts contains ions and electrons, so that it has small dielectric strength and can be easily broken down by the rising contact voltage known as restriking voltage. If such a breakdown does occur, the arc will persist for another half cycle. If immediately after current zero, the dielectric strength of the medium can be built up or increased, okay, then the arc is purely extinguished. The arcs fall to restrike and the current will be interrupted. Because this current zero position is for a few very small time, so the dielectric strength can't extinguish the arc properly. So the restriking voltage comes in operation and persists the arc. So if at the current zero time, if we increase the dielectric strength of the arc path, then it will be purely extinguish. The rapid increase of dielectric strength of the medium near current zero can be achieved by number 1, causing the ionized particle in the space between contacts to recombine into neutral molecules. If we make this electron neutral, or it converted into a neutral molecule, then the arc is extinguished, and sweeping the ionized particles and replacing them by unionized particles. If we swept the ionized particles from the contact space or between the fixed contact and moving contact, then the arc is also extinguished. So this is the low resistance or current zero method. Now the method of deionization of the medium. Therefore, the real problem in AC arc interruption is to rapidly deionize the medium between contact as soon as the current becomes zero, so that the rising contact voltage or restriking voltage cannot break down the space between the contact. The deionization of the medium can be achieved by, there are two methods of deionization. Number 1, lengthening the gap. The dielectric strength of the medium is proportional to the length of the gap. Okay, if the gap is increased, then the dielectric strength is also increased. Therefore, by opening the contacts rapidly, higher dielectric strength of the medium can be achieved. So, the deionization can be achieved. And high pressure, if the pressure in the viscosity of the arc is increased, the density of the particles constituting the discharge also increases. The increased density of particles causes higher rate of deionization. Okay. So this is the high pressure application, and by the high pressure application we can also deionize the medium. Next, the cooling. The natural combination of ionized particles takes place more rapidly if they are allowed to cool. If we cool the arc, okay, therefore the dielectric strength is also increased. And number 4, the last one, is the blast effect. If the ionized particles between the contacts are swept away and replaced by unionized particles by some blasting effect, the dielectric strength of the medium can be increased considerably. This may be achieved by a gas blast directed along the discharge or by forcing oil into the contact space by the help of force oil circulating system or minimum oil circuit breaker or bulk oil circuit breaker. Okay. Thank you. That's all for today.